In this video, we will be learning about the rain shadow effect, which influences precipitation alongside mountain ranges. Before we start, let's take a minute to introduce a few vocabulary words that will help us better understand the lesson. A parcel is a small pocket of air. We'll use this term to refer to how air moves around mountains. An arid environment is one in which there is very little precipitation. Very little vegetation can survive in arid environments due to the lack of moisture. The term prevailing wind describes the direction the wind is blowing from most of the time. The term windward refers to the upwind side of a mountain range, or that which faces the direction of the prevailing winds. The term leeward refers to the downwind side of a mountain range, or that which is sheltered from the prevailing winds. Precipitation amounts can be very high on the windward side of a mountain range. This creates moist conditions that support lush vegetation. The leeward side of a mountain range receives much less precipitation. Conditions are much drier and warmer here and can result in desert-like conditions. The phenomenon that causes these contrasts is known as the rain shadow effect. So why does the rain shadow effect take place? As air parcels move across the Earth's surface, they sometimes move into barriers, such as mountains. These air parcels can't go through the mountains, so they must make the journey up and around them. Winds blowing toward the mountains carry warm, moist air up the sides of mountains. As air parcels rise above the mountains, their temperatures decrease. The cooler air parcels cannot hold on to as much moisture. Cooler air temperatures cause the water in the parcels to change from vapor to liquid in a process known as condensation. Condensation can produce both cloud formation and precipitation. This occurs on the windward side of mountains. On the leeward side, the conditions are warmer and drier because air parcels are descending and the moisture in the air has already been released. The rain shadow effect is seen all around the world. Let's take a look at a few places where it is especially pronounced. The Gobi Desert and Tibetan Plateau in Central Asia exist in the rain shadow of the Himalaya Mountains. Can you guess what direction the prevailing winds are coming from? Precipitation is very heavy on the windward side of the Himalaya Mountains, but very little moisture makes it past the mountain range. The leeward side is very dry, and it is here that the Tibetan Plateau and Gobi Desert are found. Many consider the Tibetan Plateau to be one of the best examples of the rain shadow effect in the entire world. Only 3 to 12 inches of precipitation are measured there each year. There are also several places in the United States where the rain shadow effect is seen, such as along the Olympic Mountain Range of northwest Washington State. The Hoh Rainforest, on the windward side of the Olympic Mountains, receives more than 140 inches of rainfall each year. Towns on the leeward side of the mountains, however, are much drier. In Sequim, Washington, which lies in the rain shadow of the Olympic Mountains, only 10 to 15 inches of precipitation are measured each year. The rain shadow extends to places farther east along the Olympic Peninsula. The rain shadow effect is also observed along the Cascade Mountain Range of Washington and Oregon. Notice the lush vegetation on the windward side of the Cascades and the arid conditions on the leeward side in the Oregon High Desert. As you can probably imagine, the rain shadow effect has a significant impact on both climate and culture in areas we've discussed. The arid conditions in the Tibetan Plateau and Gobi Desert cause the region to be sparsely populated. The region is home to a nomadic population. Many of the people who live within the Tibetan Plateau and Gobi Desert often move in search of adequate food and water to sustain their lives. Farmers in areas on the leeward side of the Olympic and Cascade Mountains in the United States cannot always depend on large precipitation amounts to maintain their agriculture. They must also incorporate irrigation techniques to make sure their plants receive enough moisture to survive the growing season and produce plentiful harvest. So, let's review what we've learned. As air parcels pass over mountains, they become cooler and hold less moisture. Water vapor in these cooler parcels condenses and produces clouds and precipitation on the windward side of mountains. Most of the moisture in the air is removed through the process of precipitation. As the parcels descend on the leeward side of the mountains, the air becomes much warmer and has considerably less moisture. Conditions on the leeward side of the mountains are significantly drier, which creates arid environments.